Okay, so I will be discussing about Gauss elimination method. Gauss elimination method for solving system of linear equation. Okay, so I've already discussed the application of the system of linear equation, right? You may just refer to my previous video about system of linear equation. As I told there, it has an application in civil engineering also. Let's say if you want to solve truss, okay, you can get all the forces of a truss system using a system of linear equation. And we were also able to solve a system of linear equation using just spreadsheet. Okay, but here as another method, we will refer to Gauss elimination method. The idea is if you express the equation like this, okay, you will transform that original equation into this. So this is an upper triangular matrix because everything here from this line, from this diagonal is 0, right? So now once you transform this original matrix into this, you can uh, use the back substitution formula, the general formula, which is this, to solve the unknown variables. Now, for a system of linear equation with four equations for unknowns like this one, the general formula like this can be simplified as this. Okay, this one. Okay, so I can say that this is the general formula. Okay, once you transpose the original matrix into a upper triangular matrix. Okay, so for example, we have this problem, four equations for unknowns. Okay, we can transform that into matrix like 4, -2, -3, 6, then 12 for the constant, -6, 7, 6.5, -6, and then -6.5. Coefficient of x1 is 1, 7.5, and then 6.25, 5.5, and then 16. We have -12, 22, 15.5, -1, and 17. So this is our matrix for that. Okay. Now I have here an SMAT code utilizing the Gaussian elimination. Okay. By the way, I also compiled that in this draft ebook that I made, which you have a copy by now. Okay. As you will notice, the idea of the Gaussian elimination is, say I have this A matrix, which is the left side of the equation. Okay, just this one. I designated this left side of the equation as the A matrix, while this one is the B matrix, because we can express that, remember, as AX equals B, right, in matrix form. So this is shown in the ebook. So the command for SMAT to combine these two matrix is augment. Okay, so C colon C, yeah, colon augment, then type in the matrix name of these two, which is A and B. So if you do that and press C, okay, find the corresponding result of the C matrix, you have this. Okay. Now, if you will also notice, we will create a new matrix out of this, out of the C matrix. But first, to do that, we will pick a pivot equation. Okay. So you have different stages wherein you will choose different pivot equation. Since you have 4 equation, so you will choose the first row, say the first row as your pivot equation, first row of this matrix. Okay, so since this is the general formula, okay, so the idea is successively we will assign a pivot equation. In this case, for the first stage, we will set this as the pivot equation 1. Okay. Since the idea is to transform this original matrix into a upper triangular matrix wherein below the diagonal is 0. Okay. So on my first pivot, my goal is to make this negative 6 as 0. Okay, so I'll rewrite that first. Example, let's rewrite negative 6 and then 7, 6.5, negative 6, negative 6.5. Then write down the pivot equation: 4, negative 2, negative 3, 6, and then 12. Okay. So again, the goal is make this first element here 0. So what number will you multiply with this pivot equation to make this 0? Okay. And when you subtract this two equation, we'll make it 0. So I'll now put in minus here. Okay, how is that? Okay. By inspection, you will multiply this pivot equation by 6 over 4, right? So I'll put in 6 over 4 so that this will cancel out, okay? And then when I subtract negative 6, by the way, should be negative 6, okay? So negative 6 minus cancel out 4, positive 6, okay? So that will be 0. Okay, how about here? 7, 4, 6 times 2 is 12, divided by 4 is 3. So 7 minus 3 is, this becomes 4. So if you do the operation there, you will come up with 0, 4, 2, 3, and then 11.5. Okay, so I'll do the same thing here. So this is for the third equation. Okay, we're done with the second equation. Then this becomes 1, 7.5, 6.25, 5.5, and then 16. Then I'll rewrite the pivot equation again for -2, -3, 6, and then 12. Okay. Again, what number will I multiply the pivot equation such that here becomes 0? Okay. When I subtract these two equations. By inspection, that should be 1/4, right? So to cancel out, 1/4. Okay. Then 0, this becomes 8, this becomes 7, this becomes 4, this becomes 13. Okay, next. So we're done with the third equation. How about the fourth equation or fourth row here? Okay, I'll choose red again. So that is -12, 22, 15.5, -1, and then 17. Then write down the pivot equation again. Maybe I'll choose different color for the pivot equation. So 4, -2, -3, 6, and then 12. So this is the pivot equation. So what do we get? So what number will I multiply the pivot equation so that when we subtract that with the fourth row or the fourth equation, this becomes 0. So by inspection, it should be 12/4. Okay, so -12/4. So that becomes 0. This becomes 16. This becomes 6.5. This becomes 17. And this becomes 53. Okay, so so we will now have a new matrix. Okay, our matrix here, the original matrix here, will become this retains. Sorry, this retains. The second row will be this. Okay, the third row will be this, and the fourth row will be this. Okay, so let's rewrite that. So if I rewrite that, that becomes, so say that is matrix C. Our matrix C now will be 4, -2, -3, 6, 12. Then we have 0, 4, 2, 3, 11.5. Then 0, 0, 3, -2, and then -10. Then we have, I'm sorry, this should be 8. Wait, oops, what's happening? Why can't I erase? There. 0, 874, 874, 13. 0, 16, 6.5, 17, 53. Okay. So that's our new matrix C. Let's try 4, 8, 16. Okay. 276.5, 276.5, 3, 4, 17, 3, 4, 17. Okay. So that's it. So that's the new matrix. Okay. Now our goal is to make this element here 0. This second diagonal here. Oh, sorry. Second element here. Now earlier our pivot equation is the first row. Now our pivot equation now is this one. This is now our pivot equation. So I'll make this pink. So this is now our pivot equation. Okay? Because earlier our pivot equation is the first row. So we will do the same process. Okay? Okay, where is that? Oops. Okay. So I suggest you also write this down so that you can follow the solution. So I'm settled with this. This is already established. And this one, this is also established. Okay. So let's write that down. So our third row, 0, 8, 7, 4, 13. Then my pivot equation is 0, 4, 2, 3, 11.5. Okay. Then what's the answer? So again, what number will I multiply this pivot equation so that when I subtract this 2, this becomes 0? So by inspection, that should be 8 over 4, right? So minus, sorry, I can't write, minus 8 over 4. Okay. So this is 0, 0. This becomes 3. This becomes negative 2. And this becomes negative 10. Okay, next. So last row is 0, 16, 6.5, 17, 53. Then write down the pivot equation, which is 0, 4, 2, 3, 11.5. Again, what number will I multiply the pivot equation so that when we subtract these two equations, this becomes 0? By inspection, it should be 16 over 4. So negative minus 16 over 4. So that becomes 0, 0, negative 1.5. This becomes negative 1.5. This becomes 5. This becomes 7. Okay, so that's it. Now, our C matrix is now transformed into 4, negative 2, negative 3, 6, 12, so 0, 4, 2, 3, 11.5. Then let's now copy this new third row, which is 0, 0, 3, negative 2, negative 10, and then 0, 0, negative 1.5, 5, and then 7. Alright, now we're done with the second row as the pivot. Now let's proceed with the third row as the new pivot equation. So this is now our new pivot equation. So doing the same process. Okay, let's write that down here. So I'll rewrite 0, 0, negative 1.5, the fourth row, 5, and then 7. Then write down the pivot equation, the third row, 0, 0, 3, -2, -10. Okay. Now, uh, what number will we multiply the pivot equation so that when we subtract these two equations, this becomes 0. By inspection, it should be -1.5 over 3. Okay, minus. Okay, so 0, 0, 0, and this becomes 4, this becomes 2. Okay, now rewriting down C. Okay, so our new C matrix is okay, C is equal to 4, -2, -3, 6, 12, 0, 4, 2, 3, 11.5, 0, 0, 3, -2, -10, and then the last row is 0, 0, 0, 4, 2. Okay? So as you notice, we are now able to transform the original matrix into an upper triangular matrix here. This one. The left side of the equation is now in an upper triangular matrix. And by the equation that we presented earlier, we can now find the unknown variables. So I can copy this. Okay, so this is our final matrix C from the original equation problem here. If I interpret this matrix, we can rewrite this as this. 4x sub 4 is equal to 2. 3x sub 3 minus 2x sub 4 is equal to -10. Then this one, the second row, 4x sub 2 plus 2x sub 3 plus 3x sub 4 equals 11.5. And finally, 4x sub 1 minus 2x sub 2 minus 3x sub 3 plus 6x sub 4 is equals to 12. Now, as you see, we can now find the value of x sub 4, which is, okay, here. So, x sub 4 is equal to 2 over 4, which is equal to 0.5. Now, by substituting x sub 4 here, you can now find x sub 3. Once you find x sub 3, substitute x sub 4 and x sub 3 here, you can now find x sub 2. And then finally, substituting x sub 4, x sub 3, and x sub 2 here, you can find x sub 1. Okay, which is x sub 3 is actually -3. Okay, so this is -3. X sub 2 is actually 4, and x sub 1 is 2. Okay, so that's how you do the Gaussian elimination manually. Okay, you do it progressively, right? So you assign pivot equation on each stage until you transform the original C matrix into an upper triangular matrix on the left side of the equation. Okay, of this left side of the equation, which is your A matrix. No? You transform the A matrix into an upper triangular matrix. All right. Now, I will show you here an implementation of that in SMAT. Okay. So here we have the A matrix. Okay, how do I... There. And then we have the B matrix. Again, the command in S matrix to combine these two A and B is augment. Okay, augment that 2 matrix, we have this. Now, remember, the first pivot equation is the first row, right? So you will see that I use the first row here. Okay, the command is I extract the first row by using the command row of the matrix C, and then indicate the first, or the number 1, indicating the first row. So this is this. Okay. Now you notice that the number I multiplied the first row is actually the coefficient of the of the of the pivot equation, and the coefficient of, or the constant coefficient of the other equation. So here, remember, our goal is to make this 0, right? So our first stage there is -6, 7, 6.5, -6, right? -6.5, and then this is 4, -2, -3, 6, and then 12, right? Then we need to come up with a factor to multiply the pivot equation. What number was that? It's simply 6 over 4, which is actually this one and this one. That's why the address of that in our matrix is the first column, right, of the second row, and then the first element of the first row, right? So second row is this. Remember, this is the row 2. The address of that is C21, while the address of 4 is C11. Okay, so I hope you were not confused over there. Okay, so remember, the address of matrix is simply Aij, right? Or we're talking about row and column. So this 2 stands for the row, and this 1 stands for the column. Okay, so C21 is simply this one, okay, -6, while C11 is simply this one, which is 4. Okay, of course, we multiply that with the second row, which is -6, 7, 6.5. Okay, and I assign that new row as B1. Okay, so as you notice, I applied the same command here. So this is my pivot equation, pivot, and then this is my pivot. Okay, and the number I need to multiply is simply C31 over C11. Okay, while for the third or the last row, again, this is the pivot equation, and then C41, C11 is the factor that I need to multiply on the pivot equation. Okay, so in our manual calculation, that is actually -12 over 4. Here, in our manual calculation, this is actually -1 over 4. While here, this is actually -6 over 4. Okay? So I assign that new row as B1, B2, B3 respectively. Okay? Now, since I have now the new matrix, our new matrix C, I now assign that with the name of C1. So I combined here the original first row, C1, C comma 1, and then the second row is now my B1, the third row is now my B2, my fourth row is now my B3. Then C1 is simply this. Okay? So I'd like you to To note, C1 is actually here in our, take here. Oops, sorry. This. Okay. So this one. 40423 087413 016 6.5. Okay. Now for the next stage, this should be here. So I'll repeat the same process, right? But this time my pivot equation now is this one, right? So this is now my pivot equation. This is now my pivot. Okay. So this B22 here is simply, what number was that? Negative 8 over 4 in our manual calculation. While here, that is negative 16 over 4 in our manual calculation. Okay. So I have now the new matrix for B2 and B3. Okay. And now the C1 earlier is now transformed into C2 here. Okay. Which is this one. Okay. So I'll copy that again so that you will recall what we did in the manual calculation. So that is actually this. Where's that? Right? So 0, 4, negative 2, negative 3, 0, 4, 2, 3, 11.5, 0, 0, 3, negative 2, negative 10, negative 1.5, 5, and 7. Okay? Then finally, for the last transformation of C2, our pivot equation in this stage is now this, right? Now this coefficient is actually negative 1.5 over 3, which is this one, in our manual calculation. Okay, so I now denote that as final matrix. Okay, and what I did here is simply, this one is actually this one. Okay, and then final matrix is here. There, right? So 4, negative 2, 4, 2, 3, 11.5, 3, negative 2, negative 10, 0, 0, 0, 4, 2. Okay? So I got the same answer using SMAT. 0.5, negative 3, 4, and 2. Okay? So the good thing about creating a code or a spreadsheet using SMAT is, if ever there's a 4 by 4 or 4 equations, 4 unknowns problem like this, you can get the solution right away. Okay. Okay, so I think I don't need to demonstrate the solution of this using Excel, right? Because we already have a video of that. So you can simply check the answer using Excel, which is using what function again? Using using mean verse, okay, and then mmol. Yeah, okay.